welcome you all. In this session we are going to see a course on PLC and Scada. Types of control. So there are three types of control we have: temporary control or state control or hybrid. So here in temporary means it's control based on time. In state it's based on the level, and in hybrid both on the time and state. So on these basis we can control a system. Purpose of program logic controllers. Initially designed to replace relay logic ports, sequence device occasion and coordinate activities, accepts input from series of switches and provides output to various devices such as relays. Functions of controllers: on-off control, sequential control, feedback control and motion control. Various control devices we have are mechanical control like governors, cam, etc. Pneumatic control like compressed air valves or something, etc. Electromechanical control comes switches, relays, timers, counters. These all comes under electromechanical control. And electronic control, which similar to electromechanical control except the electronic switches. So here the electronic switches alone comes under this category, all other comes under electromechanical category. And finally the computerized control. So in computerized control we go for this with the help of actuation system, that is Scada. You can go for controlling certain system. This slide shows the basic block diagram of a PLC system. It consists of a CPU system, ladder diagram, working memory registers. Then the second layer consists of input flag and output. And the final we have input module and the output module. So through the input module we get the input datas. Finally through the output module we are providing the datas to various other interfacing devices that has been connected. So these are the various switches which we use in the ladder diagram. So we have various switches, normally open, normally close, multi-pole, single throw switch, multi-throw switch. Then we have non-locking, locking switch, SPDT, DPST switch, and these are all some switches available. So these are the terms we used. Throw means number of states, so on off, it's a two throw switch like that. Then the second one is pole, number of connecting parts we have. So these are the things we have. So you can see the various terms that we used in switches. Various types of switches we have are basic switch, second one push button, third one slide switch, a fourth one thumb wheel switch, fifth limit switch, sixth proximity switch, and the seventh one photoelectric switch. These are the switches we have, and they work on the basis of voltage or current. These are the various types of relays we have. A relay is nothing but a switch whose operation is activated by electromagnet, is called a switch. So it has a coil and a contact. You can see the diagram and the symbolic representation of a relay. So counter, digital counter output is in the form of relay contact when pre-assigned count value is reached. So whenever a count value is reached, it provides the output. So this shows the counter input output. Here we have three terminals: input, output and a reset terminal. And here the diagram shows that with respect to time. Timer. A timer consists of internal clock, a count value register and an accumulator. It is used for timing purpose. Here you can see the block diagram of a timer. You have a clock, accumulator, register and a contact. So either you can reset it or you can get a output with respect to the count value. An example of relay logic. For a process control, it is desired to have the process start by turning on a motor 5 seconds after a part touches a limit switch. The process is terminated automatically when the finished part touches a second limit switch. So you can see limit switch 1 and limit switch 2 here, LS1 and LS2. So when it's LS1 is touched, it starts, and when it reaches LS2, it will be automatically turned off. The emergency switch will stop the process anytime when it is pushed. So you have a push button, so if you push it, the emergency, so here you have an emergency switch, it turns off automatically. So this is the example logic, and here you can see the logic diagram for the particular case and a block diagram for that case. So with respect to time, for again I told it runs for normal case, it runs for 5 seconds. So we have utilized a timer for 5 seconds so that the motor runs for 5 seconds. Various components of PLCs. The first component is the processor. Microprocessor based many allow arithmetic operations, logic operations, block memory moves, computer interface, local area network functions, etc. Second one is the memory, measured in words. So various memory associated are ROM, read only memory, RAM, PROM, EPROM, PROM. So these are the various memory associated with PLC components. So the I/O device, input output device, or modular plug-in periphery, AC voltage input and output, DC voltage input and output, low level analog input, high level analog input and output, special purpose modules, examples high speed timers, stepper motor controllers such as PID motion. These are some input output components associated with PLC. Supply, it is based on AC power supply, and peripheral devices we have are handheld program, that is the loader, CRT programmer, operator console, printer, simulator, EPROM loader, casket loader, graphics processor, and the network communication interface, map and LAN. These are the network communication we have. Thank you.